All right. Hello, everyone, and welcome to the stream. We're doing an extra one for tonight. So, just kind of trying to get a couple things sorted out here. You guys probably already saw that I accidentally had the credit screen up, so I'll go ahead and hit that real quick. I did finally sort out the issues I was having with this so that everybody here is listed. So I just want to take a quick moment to thank all the supporters of this channel and my YouTube channel. Starting with the partners who are the highest tier on YouTube and Patreon. So that is Caden Parker, Airslea, Gerbolis Inc., Paul S., Super Awesome, and Wenchang. And I'd also like to thank all the other supporters here as well for their support. This includes the Twitch subs as well. So thank you all very much for your support. In addition, I would like to support, or thank you for supporting me rather, by just following along with the series and being here along with me and viewing and interacting and so forth. So thank you to all of you who are joining me here today and who have joined me here in the past as well. So with that, I want to go ahead and just mention as well, this is designed to be an interactive stream. So along the way, if you guys have any questions or comments, feel free to drop them in the chat. I am watching that, so I will pay attention to that to the best of my ability, and we will, interact and go back and forth as much as you guys want. So, Mighty, hello, welcome. Okay, so on the agenda tonight, we're going to pick up kind of where we left off last night, which was we had put in some frame data that is basically holding things like frame delta time, the total game time, and for right now, the frame allocator. And that way we can sort of access those things in a variety of places wherever we need them to process specific frame data. And before we kind of jumped into that, we also scaffolded a quick scene, just kind of following the outline that we had brought up the night before. Let's see, do I still actually have that open? Probably not. So I'll dig for that right now. So we just have this sort of outline of things that we've done, and I sort of discovered that that frame data needed to be done. So we're going to continue with this tonight. But before we do, I want to address something that a YouTube commenter brought up that is a very, very good point and something that I classically forget all the time working in C. If you've been following this for any amount of time, you'll know that I initially come from the C++ world and eventually went over to C. And I did that for a number of reasons, one of them being language simplicity. Of course, compile speed is another one of those things. I don't use a lot of the C++ features, so there's no reason to be using that. I might as well just use C. Anytime I use C++, it was C-like C++ anyways. So I made that jump. But one of the things that I kept consistently forgetting was that whenever you have a function that does not take any parameters whatsoever, let me see if I can find an example here. So for example, we have this engine on event system initialized. We should be putting a void here. And I was not doing that. I did it in some spots, but I wasn't doing it consistently. And the reason for this is unlike C++, in C, this actually means it is undefined as to what parameters are going to be passed here. So we could technically have our function signature look like this in the header file and then have a whole bunch of parameters in our C file, and we'd never really know the difference, right? And of course, that can lead to all sorts of bugs and undefined behavior and things that are just generally nasty, right? So the way that we tell the compiler that, hey, there is definitely not supposed to be anything passed here, is we put void here. That is not a requirement in C++. In C++, it does accept this, but it doesn't actually require this to be true. In C, it requires this to be true to say, hey, I know for a fact we're never going to pass anything to this. So I've actually taken the liberty and gone through the entire codebase and found all of the instances of that. And I've gone ahead and updated them. So there's a number of files here. As you can see, there's 85 change files. Most of these changes are actually circulating around that. There are a number of changes that I also made, quick little bugs and stuff that I found along the way. And I want to just kind of quickly step through those as well before we actually merge in this code. But before I do, I also added something else in here to catch whenever we do this in the future. So I've gone ahead in the make files and added some additional things here. Let me actually get out of this view and bring up the full thing here. All right, so you guys can see that. I'll get rid of the console as well. All right, so we've added a couple of things in here. We had wall for, which basically gives us a bunch of, turns on a bunch of warnings, right? Compiler warnings. Then we had where, which basically treats any compiler warnings as errors. But we actually needed some additional things passed to that. So I'm using wextra, which turns on a whole bunch of additional errors that wall doesn't actually catch. Which, you would think wall would be all of them, right? But it's not. So this catches sort of all of the basic issues in your code, right? Extra catches a few more of those things. So there's that. And then I've added a number of additional flags here to the end, right? So there are a number of changes that I've made to the Codebase to support these changes. So one that's super important is this w-strict prototypes, which I think might have been caught by wextra. I can't remember, but I put it in here anyways. This is the one that will not allow us to actually have empty prototypes, right? We have to either say void or we have to pass parameters to it. With that, there were a couple of these things that were in this wextra that were kind of annoying. And one of those things was the unused parameter. So in the examples rather, where we had systems that maybe took a config parameter but then ignored it or didn't use it, unused parameter, which was included in extra, would actually treat that as a warning, and then thus it would be converted into an error. I didn't want that, so I did that by putting in the no unused parameter, right? So in general, if you have a flag here that is set like unused parameter, this will say, you can't use unused parameters, right? Or you can't have them. By adding no dash in front of that, that turns that off. So it's technically turned on by this guy and turned off by this one, okay? So there's that one, and then no missing field initializers. So this one is basically turning off the requirement to have field initializers in things like when we're setting up the Vulkan structures. Let me see if I can find an example of that in here. It's probably actually going to be in the Vulkan backend. Yeah, so like this guy here, right? Where we're setting up app info, but we're only actually providing the S type. We're not actually providing all these other things within this initializer. We're doing this to sort of zero everything out, and then we're setting things explicitly, right? We could not do this if that option was turned on. So I've gone ahead and turned that option back off. So this will make our code base a little bit more strict and hopefully catch some of these things in the future. So I've gone ahead and done that for the library as well as the executable makefile, right? And in order to see these changes, you're probably going to have to do a clean and a rebuild in order to actually have that take place. But we'll just go ahead and do that real quick, right? And we should be good to go. So one of the reasons I fixed this offline is because there's 0 point in me streaming adding void to a bunch of different functions, right? Like there's no value in that. So like I said, I've taken the liberty and gone ahead and done that. There were a couple of other issues that I did run into with this as well. Let's see. So there were a couple of issues with the key bindings. So in the keybinds, these methods right here were actually wrong. So previously, these guys were treating the state as debug console state, which was actually horribly wrong. And it was basically treating that memory as if it was that thing, and then using that to pass into debug console history back and forward, respectively. And that was causing all sorts of nasty issues, as you can imagine. So I've gone ahead and fixed that here and here by treating this as the application instance and then getting the state from there and then passing the debug console. So that was an issue. If you actually had tried to scroll up or down the console, that would have crashed. So that is fixed. The next thing that I fixed is there were a couple of places where we were basically mixing signs and then doing arithmetic on it. So, for example, we had an unsigned int32 and a signed int32, and we were adding or subtracting those things. And generally speaking, that's a bad idea. It can lead to weird errors in your code, and so it's something you generally want to avoid. And those things were, I believe they were in... they might have been UI text, I think it was. Maybe it wasn't UI text. Where was it? It had something to do with... oh, I think it was actually the debug console. So, yes. It was because all of these things were signed 32-bit integers, right? So these have been converted to unsigned 32-bit integers, which makes sense because they were never negative anyway. And any code that used those was also working with unsigned integers, and so they now match up. So that was one change. And then in the debug console, I also caught a case in the debug console move down, where if the line offset is already 0, we should just boot out, right? Not even do any of this stuff. This means that basically we're already all the way scrolled down. So we don't need to do that. And I think everything in here, other than that, was all those void changes, essentially, right? And a lot of files needed it, right? So that is the reason I really did not want to do that on stream. Okay, there is one other thing that I saw come up in Discord chat, actually. So for those of you who are wondering, I do actually watch that. And that's some of you are unable to compile because we are actually missing the version.h. Which is right here. That is because version.h is get ignored. And I actually happen to have it locally here, but I've not been generating it for a while. That is because there is some sort of issue with the version generator, which I do not personally feel like troubleshooting right now. So what I'm going to do is remove the get ignore on version for now. Let's see, get ignore. I'm going to remove this for now and check in version.h, right? And at some point I'll reverse this and fix that, but it's not critical enough for me to fix right now, right? So at least this will make the code base so that it compiles for you guys. All right, so let's say get status. And let's just make sure that we are on origin main. Okay, so I'm just going to check directly into main because there's no need to make a feature branch with this. So I'm going to get add, get commit, and we are basically going to, you watch the ad 4 times because the video player crashed every time it hit 4 seconds left. Ooh, ouch. What the heck is up with that? Twitch is tripping, I guess. Yeah, that's not good. I've never had that happen before. What browser are you using? All right, so I guess I'll say added void params to empty param functions various bug fixes. Checked in version.h for now. All right. That's pretty funny. 87 files changed, but 333 insertions and 222 deletions. That's kind of funny the way those numbers worked out. All right, so let's just git push this. Oops, typed my password wrong, I guess. All right, and we'll clear, exit. Firefox had to refresh the page, and then it worked. Bizarre. Okay. I haven't used Firefox for a couple of years, admittedly. I've been using Chrome for a while. Anyway, okay, so that pretty much resolves all of the issues from the last video. So tonight, what we are going to focus on for a little bit, and I don't plan on completing this feature tonight, but we're going to make a little bit more headway. See how far we get. What I'm going to do instead is go back to our scene, right, our simple scene, and start actually building some of this stuff out. And this is actually what prompted all that stuff from yesterday, is the simple scene update, where we're just passing in delta time here. That is what prompted all this stuff yesterday. So here we're going to forward declare a struct, struct frame data, right? And then we will come down here and we'll say constant frame data pointer, frame data, I guess. How did I do that in the other ones? What did I call it? I think I called it p frame data or something like that. Yeah, p frame data. Just to avoid collision with the type name there. Right. And so for this one, we are going to performs any required scene updates for the given frame. We can actually copy most of this stuff, right? So we can say this, and then a constant pointer to the data for this, to the current frames data. And then we'll just go ahead and copy this too, because I don't feel like typing all that, right? So we had our scene update. Let's see. So just looking back at our document here. Let's see. Anyone else getting a network error? Okay, I guess Twitch is tripping. I've heard of this happening on occasion. Was actually working on my super secret project today. Descriptor sets. Yay. Yeah. Nobody likes descriptor sets. Nobody likes descriptors. They're a pain. Okay. So, we have our create, destroy, initialize, load, unload, update. And we still need some method to obtain renderable data, i.e. the geometry render data, right? So I'm thinking that we not only include render data, but we include any of the data that we might need for rendering, not just geometry, but anything like our skybox, our light data, all that kind of stuff, right? And I'm thinking that all probably belongs in our render packet. So I'm thinking probably what I'm going to wind up doing with this, now that I think about it, is this is going to generate a render packet per scene. Now, since we can technically have more than one scene, we should probably just pass the same render packet to every scene and have them all add to that, I'm thinking. We could just have them add to the same packet, and then that whole packet gets passed over to the renderer to be rendered. that's kind of what I'm thinking that we should go for. Shader reflection is love. Shader reflection is life. Yeah, I totally agree. At some point, we're going to be doing that, right? So I came by to say hi, bug you a bit, then disappear. You know the usual. Yeah, I know the usual. I just have a big fat array of all the renderable data. That's more or less what I'm going to wind up with. Mine is separated out a little bit differently because I have different sets of data for different things that I'm doing. So it's a little bit different for me, but not too much, right? It's a few arrays, some of them fatter than others. All right, so I guess we can call this B8 simple scene populate render packet, because we're not creating it, because the packet's going to be created and passed to us. All we're going to do is fill it in. How many bugs? How many bugs with what? All the bugs. So I'll go with simple scene. We're also going to pass frame data to this, just in case. I don't know if we'll need it, but I'd rather have it than not. And then, do I want to pass just the render packet? I think I'm going to do this. Struct render packet. Declare that up here. And that, I think, is going to be enough. Cool. I just realized almost all your bookmarks are Japanese. You're clearly doing more than I have been lately. I actually have been slacking huge on my Japanese lately. It's been a long time, actually, since I've seriously studied it. A lot of those bookmarks are like years old. All those pointers. Yeah, I know. Pointers. 90% of my code is nothing but IDs, handles that redirect to arrays. It's still a level of indirection, though. See, I started off doing that, and I found it to be... yeah, I found it to be a huge pain in the ass to actually do it that way. And I didn't find it to be much different performance-wise at all. Now, obviously, when you scale that way up, I'm sure there is going to be a difference, but I don't know. To me, it's just a lot easier to use pointers. Imagine not using references. Well, I am using C, so don't make me regret my choices. Well, I actually started several of the systems in this doing that, and I think I'm going to wind up getting away from it. In some cases, not all. There are some places where it makes sense to do that. Things like this, though, I don't think so. Cool. All right. So in this case, we are going to populate the given render packet with data from the provided scene. Oh, this should be updated. I was just about to copy this comment, but it's actually wrong. P-frame data, that's the same thing too. So we've got that, and then same thing is going to occur here. A pointer to the packet to populate. All right. Now, there are a few other things that we are going to need. So let's take a look at our scene notes. So we have some method to obtain renderable data. So that is actually going to be populate packet, right? We'll just call it that for right now. Pretty much all of my renderer objects are smart pointers that are just named handles. Yeah, I mean, if you're using smart pointers, that's definitely a way to go. Look at all that pretty documentation on like my code. Yeah, I'm trying to actually keep the entire code base documented, mainly because you can go here to kohiengine.com and go to API documentation, and you can get a list of like the data structures, right? And let me find a good one, right? And get auto-generated documentation. So every time I push to the main branch on this is automatically generated by Doxygen. Yeah, it's pretty cool. Doxygen is good stuff. It's been around for a long time. I love it. But yeah, this allows me to have this for anybody that's trying to use the engine and doesn't necessarily want to pour through the code to try and find something. This is here, right? You completely ignore that you have it. Yeah, I'm trying not to do that. I'm trying to actually like have real documentation and treat this like a real project. Eventually I'll have like a wiki and all that stuff too. I've kind of built like a small wiki, but it's not very filled out at all. I think there's only like 3 or 4 pages. But yeah, so anytime I'm doing a feature, I kind of just like outline some of my thoughts like this. I know, a real project. It's crazy. How dare I? How dare I? When did you start this? This, do you mean the project in general? If you mean the Kohi engine in general, I started this in 2021. Let me see, what was the... I don't remember what the, if there is a way to tell like when this was created on here easily. I suppose I could look at the commit history and just go all the way back. Is there a way to like sort this? Probably not. Probably have to just page through all the commits. Whenever this repository was created, is basically when I started it. So there's a lot of commits here. I know it was 2021. I think it was like, was it April? Nope, sooner than that. February 28th. Initial commit. 5 years ago. Yeah, no, not 5 years. Well, okay. Wait. No. My YouTube channel started 5 years ago, yes, but that was not this series. So I've had other series on my YouTube channel. Oh yeah, I guess it is a 2-year anniversary. Holy crap. I didn't even realize that. Yeah, we're actually a little bit past this. Huh. I didn't even think about that. Yep, this has been in development for 2 years. That's pretty cool. I mean, I haven't been Twitch streaming that whole time. I've only been streaming on Twitch since January. So you're trying to write a custom engine so you can have new capabilities for more improved performance. So I am writing this as a educational exercise, as well as I want to write a lightweight engine, right? So Unreal and Unity are fantastic engines, but they are big, right? They're huge. And I am not a huge one of using, pre-boxed much of anything. I much prefer to roll things myself and only kind of write out what I need as I need it, right? So the idea behind this whole project is to create or show a way of creating an engine from scratch. It's not the only way to do it, for sure. There are many ways to do it. This is just my way of doing it. And hopefully with that, it'll help people that follow along with the project to understand everything that goes into making an engine, and understand the underlying concepts and tech that go into it, as well as all of the pain points you'll run into along the way and all that stuff. That's kind of Yeah, so it's really it's more or less the resource I wish I had when I was learning how to do this stuff, if that makes sense. A teaching tool of what not to do. Yeah, I mean, you're not completely wrong, right? So one of the parts of this is I'm also broadcasting all the mistakes I make, right? Because anybody can put together a tutorial series that's perfect and works from start to finish, and everything's perfect and honky-dory, and you never run into any errors and never run into any issues, and that's just not realistic. So part of this education is also, thought process behind design, decision making, and troubleshooting, looking through the errors, like what does this mean? How do I fix this? Where do I look? That kind of thing. I do agree with you because it's true. And Twitch is dead again. Sweet. Yes, I am using STP TrueType for font rendering. So there are a couple things I'm not rolling from scratch. So image file loading is one of those things. So I'm using STB image, and STB TrueType is the other one of those things because yeah, exactly. So you've been working on font rendering for 3 years. Yeah, exactly. I don't want to do that, right? So that's those are a couple places I made a concession to skip around that, because it's not really going to benefit the engine per se for me to roll that from scratch, right? Now, what I am going to do is I'm going to have a utility to convert those things to my own proprietary binary format, so that I can just sort of jam them into memory directly from disk, and not have to process those files. So that is one thing I'm going to be doing. I haven't done that yet. I've done that for mesh data. I've not done that yet for textures or fonts, but that's another thing I'm going to be doing. And then we can load directly from that proprietary binary format and not have to have these libraries included. So in the runtime that you'll be shipping the game with, it will not actually be present there. Those will be extracted, put into tools that go along with the editor that we're going to make and all that stuff. And it'll kind of sit alongside the engine, but it won't be in the final runtime. Let's see. My front-end API is slowly evolving. My back-end API is changing every single day. Truth. I fully understand that. If you need ligatures kerning, and I have a written header C-only library that does open type shaping on top of SP. Oh, okay. You know what? Go ahead and drop a link to that if you have like a GitHub profile, and I'll check it out. Because that might be something I am going to explore a little bit of advanced font rendering at some point. Anyway, time for me to disappear. I've got a few Zelda bosses to beat up. Awesome. Go beat them up. Star, star, star. We're actually, instead of dropping it here, go hop onto the Discord server. Do I have a... I think there's a link in the channel info to that. But yeah, go post it on the Discord server and tag me in it, and then I'll see it. Cool. All right, where were we? So we have all these. It has a scene transform. So the scene transform is probably the next thing we need to add. For that, we're going to need include math types, and let's put that here. Oh, you know what? Yeah, no, this is fine. Scene transform. I don't really like the... I'd rather just call this transform, but that's already called transform, so I'll just stick with it. All right, what is next? Can be enabled, disabled. I think I already have that flag in there. Enabled, yes. Okay. Should have general states. Yep, we already have that. Okay. So we have our general interface sort of worked out. Now, granted, we're not implementing this yet, right? We haven't created this interface yet. We're kind of testing the waters on that in our non-ECS simple scene. Uses generic scene interface, adds or removes renderable types directly. So this is where we're going to add meshes, skyboxes, lights, things like that. So we'll have an add remove for each one of those. So probably the best way to do this is, where did I define directional light? I think that was in light system. I think that was an H, right? Okay. So I think we can actually forward declare these things. We don't need them in the header file, right? So I'm just going to copy these guys. Come down here. Once again, we'll do B8 simple scene add directional light. These function names are kind of getting ridiculously long, but such is the way in C sometimes. So we'll need scene, and then we'll also need a struct directional light pointer, right? Which means we need to forward declare this guy. We'll do that there. And we're also going to need the point light, right? So I'm just going to copy this, go here. And actually, I'm just going to copy this and rename to point light. Now, for when we get ready to set up our ECS scene, as it were, once we have our ECS and all that stood up, these direct types won't exist, right? We'll just be adding components and objects. Cool. Hey, TNT. How's it going? Late today again. No, that's fine. I started a few minutes late myself. You missed the stream from yesterday, but you watched it. That's cool. Yeah, no worries. All these will be archived on the YouTube channel anyways as we go, so no worries on that. Okay, so the next thing we probably need to do, working on scenes. Yep. So we're just kind of scaffolding out what our scene sort of interface is going to look like for our simple scene, because we got this frame data stuff done yesterday, so we can finally actually move on to this. So we've got lights. We're going to need meshes. So I think, if I recall correctly, oops, testbed main. I think we are just using meshes themselves. So we should probably just do, yeah, just mesh. So let's go up here, forward declare this, struct mesh. Just going to copy this, add mesh, right? And this is a static mesh. We're not calling it a static mesh. I may have to reword that at some point, because we are going to have skeletal meshes at some point as well. So we have that. We also need the same thing for skyboxes. So struct skybox. And I think we can use those as is right now. So add skybox. Skybox. We need to change this to mesh. Just call that M and SB. Right. And I think that's probably good enough for now, right? So this is what we're going to do to add them. We're going to just stick with adding them as pointers, right? Which means that they're going to be, if we do it this way, the pointers are actually going to be owned by something other than the scene, right? It means that probably our game will own it or something else like that. If we load them through configuration, then the scene itself will actually own those things. So the way we're probably going to do it is no matter who owns it, the scene is going to control whether it's initialized, loaded, unloaded, whatever. So even if our game winds up owning the actual mesh itself, it doesn't mean that the scene is going to you don't have to worry about the life cycle of it, right? That should be fine. All right. So what is the next thing we need to add? Let's go back to our notes. Oh, right. We have the add methods. We need the remove methods. So those are basically going to be copy pasta of this. Whoops, not that last one. And let's see. Cool, I got your message on Discord. Oh, thank you for the follow. Appreciate that. All right. Let's see. I duplicated these, right? So I just need to change these to remove. Oops. Right. I really need to get my Vim key bindings working again. They broke recently, and it's driving me nuts that I don't have them. All right. So we have add, we have remove. What else? Add the methods to return a sim object. So, okay, so this is the next concept that we're going to have to start thinking about. So, and technically speaking, we may need to revisit these. So we need to have some way, right? We have the ability to add these various types of objects, right? The light, the mesh, the skybox, etc. For some of these things, well, not so much the skybox, but for these three, we are going to need transform information. Specifically, the light is going to need a position. I guess the directional light really doesn't need that, but the mesh definitely is going to need some sort of transform, right? Although, come to think of it, so mesh does already have a transform. I forgot I did that. So maybe we don't need that after all. I think I can skip it. All right, so initially what I was thinking, because I had forgotten that I added transform to mesh directly, which probably we are going to want to refactor away at some point, is I was thinking we need some sort of wrapper to combine a transform and one of these renderable objects. But technically speaking, each one of these things has what it already needs to be able to use it as is. So I am actually fine with leaving it the way it is for right now. We are probably going to have to separate mesh and transform at some point, because really a mesh should just be a collection of geometries, and that's about it, right? Transform doesn't really belong there. Transform should come from something else. Should I change that now? I don't know if I should change that now or wait. I'll think about it. But these other things already have kind of what we need, right? So a directional light, you can set the direction on. It doesn't have a position or transform, right? You can't rotate it, etc. It just has a direction. A point light also does not have any sort of rotation or scale or anything like that. It does have a position, but it also has its position that it's needed. It needs that in order to actually function. So these two things don't need any sort of object like that. The only one that will really need that is a mesh. So I think for right now, just to kind of get this up and running, I'm going to roll with it as is. But at some point, we're going to have to come back and take out transform here, because that really doesn't belong there. All right. So we have add, we have remove. I am going to skip this for now. Where was that? I'm going to mark this as skipping for now. Let's see. So pointers to renderables are stored in internal lists for each type, right? So we need those. So I guess that's kind of the next thing that we need to do. Each renderable is added to an internal sim object that has a unique ID. We're also not going to do that right now. The ECS system is really going to make use of that. I don't think our simple system is going to have to. So skipping for now. Should have its own file format with nestable objects. This should be traverse depth first. Okay, so this is about the file format to load that. We'll come back to that after we get the other stuff up and running. So really, the next thing to do is create the internals of this, create the lists, and then start filling out all these functions. So I'm not going to comment these ones for right now because I'm not 100% sure that's all we're going to need. So I'm going to wait on that and just start implementing and see where we wind up. So I'll take basically all of this and come over here and we'll create our C file. So simple scene.c include simple scene.h. Go through here and just remove all these things real quick. Oh, and you know what? There is one more other step that I'm going to have to do that is going to get in our way if I don't do it now, and I will definitely forget. And that is all these functions need to be exported. Right? So let's go ahead and export them all. Because more than likely we're going to be calling this from game code, which is external to this library. So these need to be exported. Oops. Suppose I could have done a find and replace on that. Whatever. All right. Okay, so all those are exported. All right, so we should be good on that front. So obviously we'll have to, you know what, I am going to find and replace on this one. Well, let me do that, I wonder. Let's see. Yes, it will. Okay, cool. All right. So the first thing that we need to do is create a scene. So the configuration, as you recall, is optional. So the only thing we really need to validate here is do we have an out scene? So if not out scene, we are going to want to bleat about this. So we want to include our core logger, right? And this is going to be a k error, right? Because we can't even create the scene with this. Out scene is required. A valid pointer to out scene is required. And we'll put this in there as well, just to be explicit as to where this is, and we'll return false. Right? Okay. As for the other properties, so we have enabled, ID, scene transform, state. Let's go ahead and zero this out, right? Because we don't know where this memory came from. We don't know if it's zeroed out or not. We don't want to trust that. So we're going to say include core k memory. And we'll say k0 memory out scene. Oops. Out scene. Size of simple scene. Okay. So out scene enabled. We're going to explicitly set this to false, right? Technically, but this zero memory would do that for us, but I'm going to explicitly set it there. Let's see. So our simple scene state. What is this again? I think that's just an enumeration. So we want to go with uninitialized. Again, it should be 0. We are going to explicitly set it. Let's see. Yes, the library works as expected, but it's work in progress. Basically, the only thing is when parsing from the OT tables, the size of the allocation is not really well defined to store the results of the parser. So instead of trying to write a complicated allocator, I'm just allocating from one large block. And I think I'll just add a macro so the user can control the size of that. So each thread would have its own constant size block of memory and simply reset the allocator after shaping. That makes sense to me, at least on the surface. All right, scene transform. I think I need transform for that, actually. Math transform.h. Transform create. Okay, so that'll create a zero position, 1 scale, 0 rotation transform for us. And the ID, this technically needs to be a unique ID for the scene. I suppose for right now I could just have a static counter that increments every single time. I think that's fine. So I'll do static U32 global scene ID equals 0. And then we'll say global scene ID plus plus, and then we'll set this to global scene ID for now. All that's done, return true. Okay. We're not processing any config yet, right? So to do process scene config, right? We don't even have a type for this yet, so I'm just going to leave that there as a to do. Okay, so that's creation, at least in part. So the other thing that we're going to need in the scene is that list that we were talking about. These guys. Pointers to renderables are stored in internal lists for each type. So really it's going to be a list of pointers, which means that we're actually going to need to add that to our structure here. And since it is an array of pointers that we're going to be keeping, or several arrays of pointers, we can actually use the forward declared types that we have up here. So we have these things basically. So I'm just going to paste these here. And I'll say directional lights. This will be point lights. And this actually needs to be a double pointer because it's an array of pointers, right? And then meshes, and then skyboxes. I would argue that directional lights and skyboxes should really only be one thing. We shouldn't be able to add more than one per scene. That's what I'm thinking. So I think that's how I'm going to actually do it. So I'm going to call this dir light, singular, right? And it's just going to be a pointer, right? Singular point, if I can type, pointer to a directional light. And then this list is basically going to be a D array of point lights pointers to point lights. This is likewise going to be a D array of pointers to meshes. And this is going to be just a single pointer to a skybox, which I'm just going to call SB. So singular pointer to a skybox. Right, and we're doing this because at least the way I'm thinking about this is each scene is only going to need one directional light and one skybox. It makes no sense to have more than one. So that is the way I'm going to structure that for right now. So with that, I'll go back to this and we'll scaffold some of those things. So I'm going to need include containers darray, and I will set my out scene. Let's do the point lights equals darray create point light. And now that we're actually using this type, that's probably going to bleep because we don't have point light defined. So we're going to need include systems light system. And that'll give us the point light type, the actual type. And that's going to be a darray of type point light pointers. And then we also need to set up the meshes as a darray create mesh pointers rather, right? So this type is in resource types. So we're going to need, let's put that here, include resources, resource types. And that'll give us our mesh type. There we go. And then, again, this is just me being explicit here. I'm going to set the directional light to 0 and the skybox to 0. Okay, so there's our internal lists of renderable objects. And so anytime we add one, obviously we'll just be adding them to this list. Okay. Let's see. Looks like we have another round of ads starting in about 50 seconds. So I will see what I want to do next here. I guess I'll go ahead and start with the destroy. So first off, if not seen, return false, right? Cannot actually keep it the same. Requires a valid pointer to a scene. Otherwise, let's see. Posted in resources about the project. Perfect. Perfect. That's the perfect place for it. Okay, I will be right back. Ads. All right, and we're back. So, real quick question. Can you guys, I just realized that my ceiling fan is on hurricane mode. Can you guys hear that at all, or no? So I'll turn it down. I've been painting my office in here, and I had that going to dry off the paint, and I'm not sure if you guys can actually, it's coming through the mic or not. Okay, so our simple scene destroy. Our rule about this, can't hear it, perfect. Okay, cool. Our rule about this was, I think I had put in here, maybe I didn't put it in here, I might have put it in the comments, that basically, when we go to destroy a scene, it performs an unload first if the scene is loaded, right? So that's going to be the next thing we need to check, right? So at this point, we verified the scene exists. Now we can say if scene state equals scene state loaded, specifically loaded, right? We may need to handle some of these other states as well. But in this case, we need to do a, I guess we'll say a B8 result equals simple scene unload scene, right? So if the scene is actually still loaded, then we're going to unload it first. And then once the scene is actually unloaded, then we can go ahead and start destroying stuff. So in this case, once that's done, we'll check the results. So if not result, like it failed to unload for some reason, then we'll bleat about it here. So k error, we'll say that it came from this function, failed to unload scene before destruction, return false. All right. Otherwise, if we are not in that state, there is the possibility that we try to call destroy when we're like loading or when we're currently unloading. And I'm wondering what we should do. I've got some ideas, I think, on how we can handle that. So I'm going to come back to that, right? We're just going to keep this simple for right now. So now that we've destroyed, or we've made sure that it's unloaded, the next thing is going to be to tear this stuff down. So really it's just these two arrays. We need to free those. So if scene point lights d-array destroy scene point lights, and we're going to do the same thing for meshes. All right, so we'll destroy those. We'll also say, I usually would set these to 0, but I'm actually going to 0 the memory out at the end, which I could just copy this from here. So all the way at the bottom, we're going to 0 out the memory. This is going to be just scene, size of scene, right? So we're just going to 0 this out. That way it's super obvious that anything that's holding onto this, that this is not valid. Let's see, what else is in here? Transform doesn't hold any sort of dynamically allocated memory of any kind, right? It's just all flat data. It can hold a parent to a parent transform, but really something else is going to own that. So I think it's fine to just go ahead and 0 that out, which will be handled by this. So if we get to this point, then we're golden, right? Return, whoops, true. All right. Okay, so that is destroy. Initialize. So our rule for initialize, or our idea behind initialization, was to perform initialization routines on the scene, including processing configuration if provided and scaffolding hierarchy. Now, for a simple scene, we're not actually going to have any hierarchy yet. We are going to have the ability to maybe parent stuff at some point, but I'm not going to start off supporting that, right? We're going to keep this nice and simple and deal with a flat list of objects for now. And then we'll add a hierarchy later. So for right now, I think the only thing that we would do here is process configuration, which we don't really have yet. So again, we're going to want to do our sanity check and say if not seen. Let's just copy this error message and replace the function name, right? So it requires a valid pointer to a scene. Grammar, right? Okay. Okay, so if that doesn't initialize, or if that doesn't exist, then we don't try to initialize it. To do process configuration and setup hierarchy. I think that's how you spell it. I always struggle with that one. Return true. Okay. So there's not really anything that this does for now, but we want it in there so that we don't have to add that hook in later, right? So that is that. Now, load. For loading, we are going to need to load all these individual types on their own. Now, some of these things aren't going to need loading. So, for example, the directional light doesn't need to be loaded. It doesn't, whoops, what happened there? So it doesn't need any sort of resources, right? A point light doesn't have to be loaded, but a skybox and a mesh do. And so what I'm going to do actually is I'm going to go to our testbed main, where we are actually, let's see, where we are actually loading this stuff. So this is the UI stuff. Let's go ahead and grab, it's going to be up here. So we have a number of things that we do. So we obviously get a pointer to that thing. We give it a unique ID, which should be done probably before the scene gets it. Although I suppose we could have the scene hook into that and not have to worry about it. I don't know if I want to do that yet. We assigned it a transform, probably something else we should also do. These things I feel like would come from configuration, right? So this part actually makes sense here. So this would basically be the equivalent of what our configuration is going to do. Same with this guy. I guess we should probably look at the way these cubes are being done, right? So we're generating our configuration. It's kind of the same thing though. So we're setting transform parents here, something that's basically going to be our parenting. Yeah, so none of the loading is actually happening here. That's going to happen further down. Let's see. Didn't I actually have a... Where is the... Oh, this is all our view setup. It's going to be up here somewhere. If a mouse can stop going off screen, that'd be great. Initialize. Application boot. Where do we do that? Here we go. Here's our load and our unload. So I think all we have to do, we're loading this from a resource. To a mesh. So the thing we would need to figure out is, are we loading from a resource or are we loading from configuration? So this mesh load from resource basically loads up a configuration for a mesh, versus configuration would do that kind of for us. Let me think. OS Good evening, welcome. We are just trying to figure out how we're going to move a lot of this code over to scenes right now. So we've kind of, at this point, jammed a lot of this stuff into our game code, and I'm trying to figure out the best way to actually move this over, right? So what we basically need to do at this point is figure out when we go to load our scene, right, are we going to load a mesh from a resource, or are we going to load a mesh from configuration? And we don't technically have enough data to tell us which one of those things are going to be true when we add this here, right? So technically speaking, we have a pointer to the mesh itself that's going to be loaded. One way that I could do this is take a string for a resource name or a configuration object. And then when we go ahead and add it, we would basically queue that up internally. So yeah, this is actually going to be a little bit more complicated than I thought, which is actually kind of a good thing, because this is getting me to think about some other things that I was going to jump into later, but we probably ought to jump into now. So there's a couple of ways that this resource adding can actually happen in a scene, right? We could just say, well, you have to add everything before you actually load the scene. And that's all well and good, but that's not realistic, right? Even our test bed doesn't do that right now, right? We load these things on demand. And so realistically, we should be able to call this anytime. And anytime we call this, it should automatically kick off a load if the scene is already loaded. Or if the scene is not yet loaded, add it to a queue that gets loaded when the scene is actually loaded, right? And so we should probably be smart enough to figure out which one of those things we're doing. So we're going to need to add a little bit more information to our scene to be able to handle that. I keep bumping my microphone here. So one way that we could do this is we could add another array for these types, right? And we can call them pending types, and we can wrap them in some sort of object or structure that maybe has a string to load a resource name, and then maybe a configuration, right? And whichever one of those things is set is the one we actually use. So we could do that. You know what? I actually kind of like the way that sounds. So let's define kind of what that would look like. So we'll say type def struct, and we'll do the mesh first. So we'll say pending mesh, right? That's what we'll call it. And this will take, obviously, struct mesh, right? It's going to take I think there's a configuration object in here for this. Cube config, geometry config, right? So we could technically, geometry system acquire from config. So the real question is, like, this is all stuff we'd get from config, I feel like. Well, technically this would be the configuration for a cube. This would happen during the load, I would think, for that. So if we were to think about it that way, we would need to do, well, but this transform could technically be done up here as well, because that would be loaded from config. But then all this would happen during the load. And we want to clean up the config as well. So technically speaking, we could have multiples of these geometry configs, right? So this one, we're just sort of hard coding the first one here. And this returns a pointer to some geometry from the geometry system. So I think what we actually need to do is we need to have geometry configs, gconfigs. We need to have an array of those things, right? I think that makes the most sense, because we can technically have multiple geometries within a mesh, right? That's kind of how our Sponza mesh works, for example. It's probably not going to be a common case, but it's going to be common enough that we want to support it. And of course, geometry config doesn't exist here. We should probably give up and put resource types in here. Sources, resource types. Where's that from the geometry system? That might be, actually. Where is this defined? Geometry system. Great. Okay. All right, screw it. I'm going to forward declare it just like everything else. I don't want to include that. All right, so I'll do this. Get rid of that. All right, so we can have multiple configs. We'll also have a U32 geometry config count. And then we can also have a const character array called resource name. We'll call this mesh resource name. So essentially what we can provide is either this or this. And that gives us the same functionality we have now. This then goes into a list that is subtracted from as these things are loaded. And then essentially the mesh moves out of this object and into this list. I think that's going to be probably the best way to do it. So we have our meshes here. I'm going to say pending mesh array, right? Pending meshes. And this is also going to be a D array, I think. I don't see any reason to use a more complex container at the moment. Of meshes to be loaded. So I think what's going to happen is anytime we add a mesh, it's going to go straight into that list. And then depending on where we actually are within the scene, we can check that list, remove items out of it, trigger loading, things like that. I think that makes the most sense. So we'll go with, we have pending mesh, and then skyboxes also have to be loaded. So oops, let me go back up. So you have skybox, I think it was skybox create. Yeah. Skybox create, I think, does all this stuff on the fly, though. So this is actually kind of bad. And the reason this is bad is because this doesn't align with the way that we're kind of handling our other resources, where we have sort of the creation of that resource that's more or less unloaded, right? So it's configured but not necessarily loaded. And then we have a loading sort of state, I guess you could call it, where we go ahead and we acquire the resources like this, right? So we acquire the texture map resources and the texture, which that would happen in load. Like this cube config, that would happen. That should happen up here, like in an initialize, and then the geometry acquire from config, that should happen during load. And then again, acquiring shader resources, that should happen during load. And then we should have a unload that kind of undoes these things, which it looks like we're not undoing everything either, which is awesome. Okay, so we probably need to adjust the way we handle skyboxes a little bit, because this is not going to work with the way that we have it now. Okay, so we have this in initialize. And I think we'll probably go ahead and just keep all these calls together here. But we are going to split this up. Let's just do this now, because I thought about doing it last night. I didn't, and now I'm kind of regretting it. So KAPI B8 Skybox initialize. And then this is going to be Skybox SB. So we have some initialization that goes on, right? So we kind of create the configuration here. We do some preliminary initialization here. Then we Skybox load Skybox SB. And then we have also an unload there. Yeah, I think that makes more sense. So let's go ahead and split this up, because we took some shortcuts here that really are kind of biting us now. Right, whoops. By the way, if you guys have any questions on why I'm doing what I'm doing, feel free to chime in. Trying to be as clear as possible about explaining this stuff as I go. So let's see. So this kind of initialization stuff can happen here. Pet on stream. Pet on stream. Let's see. Who do we have? I will grab the demon kitty. Hold on one second. All right. So this is Rin. He is currently horribly confused as to why I'm holding him up. And he's also probably pretty sleepy. But this is, I call him Demon Kitty because he's kind of a jerk. He likes to bite, and he likes to fight the other animals. But he can be a cool little dude every once in a while as well. Right now I think he's sleepy and horribly confused. Oh no, not that one. Yeah, I picked this one. This is the one that, well, let's put it this way. The big one is down there on the floor, and I can't really lift him. So I may actually show him by moving the camera, but this is Rin. So he is our other cat. He's a couple years old. I think he's like 4 now or something like that. I forget. 4, maybe 5. there he is. He's sleepy. I think I'm going to put him back down. And then I'm going to do 2 for the price of 1 here. Let me see if I can get my camera to look at him real quick. Right there. That is Sparky. So he's our old man. He is 13 and change years old. So he's a little hard of hearing recently, so as you can probably tell, like, he doesn't even know I'm talking about him. I could say his name or whatever, and he probably won't even wake up because he's just super sleepy. So, yeah, I'm not going to wake him up either because he'll get super cranky. He's a bit of an old man, but I love him to death, you know. He's my good old boy. So that's him. All right. So that is that. Let me switch back here. Oh, and his name is, the cat's name is spelled W-R-Y-N-N. So I'll just type it into chat there. Rin is his name. It's a little bit, it's actually a World of Warcraft reference. He's the, or was the Alliance King. I guess it's not a spoiler now, it's been long enough. But, yeah, we named him after that, hoping that he would be regal. And he is anything but regal. So, yeah, I guess joke's on us for naming him that, but yeah, that's where his name comes from. Posture check, yes. I've been slouching in my chair, I can feel it in my back, so thank you for that. Cool. Alright, so stuck between Rin and Ren. Yeah, yeah, so Ren is what a lot of people tend to hear. You wouldn't have guessed Ren. Yeah, exactly. Nobody ever does until they see it written out, and then they're like, oh, okay. Which I guess makes sense because he's kind of a confusing animal, so it makes sense that he has a confusing name. One of these times, I'm sure you'll hear him getting into a fight with one of the animals in the background. I'm sure it'll happen at some point. Okie doke. So I think I'm probably going to go ahead and I guess we'll do the initialization bit. So in that, I'm going to, let's see, texture map, cube map. I guess we can set this stuff up because that always kind of happens, right? This eventually could be configuration powered, so I'm going to put it here. And change this to SB. Oops. And really all we should probably do here is just check to see if out Skybox is not there. We weren't doing that before, so we actually should be doing that. K error. Skybox create requires a valid pointer to out Skybox. Return false. All right. So acquiring the resources, that should definitely happen in load. The texture, acquiring the cube texture, that should also definitely happen in load. And we actually have a to-do there. Whoops, which I didn't copy. That the name is hard-coded. We should probably go ahead and fix that, right? So we have the... Why is that hard-coded, actually? We have the cube map name. Why don't we just use that? That's kind of bizarre. Okay, we should probably change that. But, so we want to generate the config. That can happen here, right? Because we generate the config to be used. Skybox cube config. So we clear out the material name. So we acquire the geometry from config. That I feel like probably should be done. That's kind of a load thing, right? So let's put that down here. The shader and the acquiring of the instance resources, that's definitely a load thing. So that should be here. All right. So this should be SB cube map. Does that require, that requires a pointer to that cube map? Yep, so we need the address of that. Cube map texture, so that's going to be SB cube map texture. And then we should really be, oh. Wait, what is, oh. Cube map doesn't have the underscore, okay. So the name here is hard-coded. We probably ought to change that, right? So we're passing it here in creation, which is technically part of the config. This could be replaced by a configuration object. That maybe gives us some of this stuff. But for right now, I'm okay with leaving this as is. Let's create a internal type def struct skybox config. Right, and we'll just use this internally for now to hold data. So we'll have a constant character array cube map name. And I guess the, do we want to do it this way? Because we have to hold on to that somehow. We probably should put this public, right? And then we can just say config here, right? So we have a way to transport that between stages. Yeah, instead of taking cube map name here, we should probably take the config instead. So let's do that. Right, that has our cube map name, so we can already just do that. Config. Change. Oops, change this to take a config. Okay. Oops, config. Let's just copy this and then say the configuration to be used when creating the skybox. Right? And then here we'll put a brief. That makes a lot more sense, I think. Right? So our skybox, we'll have that. The cube config. Technically, we could do this stuff here as well in initialize. So I think the only thing that we're going to do here is take the out skybox config and set it to config. Right, so we'll just copy that over for now. Keep this step pretty simple. And then in initialize, we'll go ahead and set up the texture map, or at least the properties we can set up ahead of time. Get the skybox cube config by generating that. And here we'll say SB config cube map name. right? So we get that. Material name we have nothing for, right? So that's why we're clearing that out. All right, and in this case we can return true, right? So that's create, initialize, load. We'll then essentially just do the same thing. So we'll say SB G is from the Skybox cube config. Oh, wait a minute. We aren't storing this, are we? Right. So I need to add this also to this guy. I'll call it gconfig. Geometry config, gconfig. Let me guess, we don't have this, do we? Yeah, I guess we do. My IntelliSense is all messed up. So instead of having this here, we can say sb config gconfig equals that. And we can say the same thing here. So now that will carry across. Let's see. So now we can say sb config gconfig, so that's the geometry config there. So we acquire that. We set the renderer frame number to invalid, just like we've done before. This should be sb cube map. Oh, we need the address of that, actually. Allow configurable shader. So I'm going to leave that to do. We can always add that enhancement later. I am going to resolve this to do, though. So let's see. Oh, wait, this is acquire cube texture with a given name, right? So I think we are going to say sb config cube map name. I don't know why it's saying it doesn't like that, but we'll try building it in a minute. All right, so we acquire the instance resources. So this is going to be SB instance ID, and we should be good to go, right? If all that works, we should be good. So return true if that's successful. We need our sanity checking for each one of these steps. So if not SB, we need a valid pointer. So I'll copy this down here as well, right? Because we should immediately boot out if we don't have that. And I'm going to need one for unload as well. So that's Skybox unload, which is being done by this right now. So I'm going to actually undo that and put that up here instead. So we release map resources. We should probably release instance resources too, because I think we can actually, yeah, we should be doing that too. I don't know why we weren't, but renderer release, renderer shader release instance resources. I'll need to get the Skybox shader again, which is here. I guess that should be a configurable to do as well, right? Skybox shader. Instance ID is going to be the SB instance ID. And then SB instance ID is going to be invalid ID after that. Okay, so we're now correctly releasing our resources. What next? I think We should probably reset our renderer frame number as well. And let's see, what else are we doing in here? Oh, I suppose we should probably get rid of the configuration, right? Generate cube config. Yeah, I don't think we're getting rid of that anywhere, so system wasn't there a geometry system config dispose. So we need sb config dot gconfig. We probably need the address of that, so we don't leak that. Let's take a look at the structure and see what else is in here. So the geometry itself is there, so we should probably destroy that as well. System, is it going to be release? I think, yeah, geometry. So SB G. I think that is that's already a pointer, so that should be good. We weren't doing a lot of this stuff, so that's kind of alarming. We should probably also have some sort of state for this, right? We should probably also have a way to generate the render data that we need for this particular object as well. So do I want a generic load state? Like a resource loaded state that we could use for things like skyboxes, geometries. I mean, technically speaking, we do have that in the form of generations. Because we need a way, when we go to destroy this, to see if it needs to be unloaded first. I suppose we could look at the instance ID as a flag for that. Because the instance ID is only set when we're loaded. So I guess we could look at that. So we could say if SB, well actually, you know what, we're just going to do this. We'll do the negative check first. First off, this needs to return true. True. And we can say if SB instance ID is not equal to invalid ID, then that means if loaded, unload first, then destroy, right? So now we can say skybox unload SB. Obviously we'll need to check the result of that, so B8 result equals that. If not result, whoops, K error, skybox destroy, failed to successfully unload skybox before destruction. Cool. And this is return type void, so we can't really do anything about it. We can just bleat about it, right? And then debug it from there. If that succeeds, actually we'll just return. Actually, no. We won't return. We'll go ahead and yeah, I think we'll go ahead and zero the memory out anyway. I don't have, actually it's going to be here, include core K memory, K0 memory, SB, size of Skybox. All right. So now that we've fixed this, we're actually going to have to, come in here to, I don't know how to pronounce that, Whopper System 1. Thank you so much for the follow. I appreciate that. Unfortunately, you've caught us at the tail end of the stream here, but you know, we are definitely going to have more streams coming. So, but I'm going to leave a big fat to-do here. In fact, I'm going to put a fix me so that it shows up even brighter. Handle the new create init load unload destroy paradigm we have set up, and we'll handle that on the next stream. We're out of time for tonight, simply because I do have to get up and work in the morning. So unfortunately, this is where we're going to have to end for tonight. I will go ahead and create a feature branch for this. So let me go ahead and do that. Get checkout B feature. We'll call this scenes, I guess. Simple scene. Mickey Maven, thank you so much for the follower. And we just actually hit our follower goal of 100 followers. So thank you guys so much for that. I really appreciate it. Obviously, without you guys here, you know, I wouldn't be able to do this. So that's really cool. I was wondering if you were going to hit that tonight. So just been lurking. What are you making? So we are writing a game engine from scratch. And we have been working on this actually officially 2 years now. So we're basically going through and building all of the systems for a game engine from scratch. There are a couple of utility libraries that we're using to load fonts and images, but other than that, everything else is from scratch. And the idea is to go through and do all of this on video or on stream. This started off as a YouTube channel, and now we've sort of moved to this live stream format so that you guys can kind of see my thought processes, debugging, that kind of thing. And so the idea is that this is an educational exercise that we are going to be doing for the foreseeable future, where we actually build a game engine and then use it to build games that we ultimately deploy. And so we are in the process right now of taking some of the things that we've sort of jammed into our game code and moving those into a scene so that we can load and unload scenes without having to do all this setup code. So obviously this is, you know, a long series. I think the YouTube channel is nearing 100 videos on the series alone. If it hasn't already gone over that. I know there's like 94 official episodes, and then there's a few shorter in-between ones in between there. So, you know, we've been at this for a while, and we're going to continue for a while longer. But yeah, that's basically what we're building. And like I said, we actually are at the tail end of the stream now. So typically I stream on Wednesday nights, Thursday nights if I can. This week I was able to. However, next week I will not be able to stream on Wednesday or Thursday because I have a prior commitment that I have to do, and I will not be able to stream next week. So I've actually canceled the stream for next week, but the week after that, the stream will resume. So I'm just going to create a feature branch here to check in the work that we've done so far, and I'll push that to the repository so that you guys can actually see it. So we'll put work in progress, simple scenes and skybox work, refactor, I'll say. right? And I'll push that. Oops. Feature simple scenes. All right, and that's there. So that will be available on the website for you guys to view. Let me just pull that over here. Right, so the branch is there. It's just feature simple scenes on the GitHub repo. Okay. For those of you who are wondering and want to find out a little bit more about the project, there is actually a website available that I've recently set up. Well, I guess not so recently anymore, but there is kohiengine.com. Kohi is the name of the engine we're building, and you can find all the information here about it. There are links to API documentation. We have a small forum here. It's not really active at the moment. Frequently asked questions. You can find the YouTube channel here, the Discord, the GitHub. If you want to support me on Patreon, that's another option as well as to links to recent videos. So what I'm going to do now is I'm going to go ahead and see if there is a channel that I can raid. Let's see. I'm actually going to raid Durley D's channel. So he's making a 2D game that is looking really, really cool. I really like the way that it's coming together and the way that it's looking. And he's a relatively new streamer as well. I think he started around the same time I did. So I'm going to go ahead and raid his channel. So feel free to go ahead and jump into the raid and check him out, because he's got some really cool stuff as well. And I'm going to go ahead and pull up his stream. Let's see. Right. And yeah, that's where I'm going to wrap it up for now. So thank you guys so much for joining, and I will see you guys in 2 weeks.